In this video, we will be looking at how we can apply the binomial theorem to solve some more challenging problems. So as you can see here, I've written the general term for any term in a binomial expansion. That is t r plus 1 equals n choose r of the first term raised to the power of n minus r times b to the power of r. Now it should be noted that this is r plus 1. So if we're finding the 8th term in an expansion, we want r to be 7, because 7 plus 1 will be 8. But anyways, using this general term formula, we're going to look at some more challenging problems. The first one I have here is x squared plus 4 on x to the 12, and we're asked to find the coefficient of x squared. So the first thing to do is sub this in to the general term. So doing this, we get t r plus 1 equals 12, choose r, see an n in this case is just 12, times x squared raised to the power of 12 minus r, and times b times 4 on x to the power of r. Now we can simplify this a bit more, so we get equals 12 choose r times x to the 24 minus 2r times 4 to the r on x to the r. Now the next thing we can do is this general term has to have the coefficient of x squared, or has to be the term associated with x squared. So as such, I'm going to set up that term to be ax squared, where x squared is simply, of course, x squared, and a is the coefficient of x squared. Now we know that this is the general term for this equation that we've written here, so it's just copying what we wrote above. Now what we want to try and find is, for what value of r do we get x to the 6? And to do that, we can see that x to the r comes from x to the 24 minus 2r times 4 to the r on x to the r. So when these two are times together, x to the 24 minus 2r and x to the r, you divide. Now we can simplify this general formula even more. So that's going to be 12 choose r times 4 to the r times x to the 24 minus 3r. This x to the 24 minus 3r simply comes from this times this equation here, where we get an x on the top and x on the bottom, so we simply subtract the two exponents. Now we know that we want this here to be equal to 6, as that's what we're trying to find, the coefficient of x squared. So therefore 24 minus 3r will equal to 6, and then solving for r, we get r equal to 6. Now, in order to find the coefficient of x squared, we simply sub r equals 6 back into this general equation we have here. So therefore, we get ax to the 6 will equal 12 choose 6 times 4 to the 6 times x to the 6. And as you can see, the x to the 6 cancel out, and we're left with a equal to 3784704 if you plug that into your calculator. So that's just one example of how we can use the binomial theorem for some more challenging problems. But in this case, Next question is a little bit different, and that we're asked to find the constant term of this expansion, x plus 2 on x to the power of 15. Now the first thing we're going to do is the same as last time. We're going to set up the general term formula. So in this case, it's going to be t r plus 1 equals 15 choose r times x to the 15 minus r times 2 on x to the r. Now we simply simplify this, we get the general term is equal to 15 choose r times x to the 15 minus r times 2r on xr, and then simplifying even more so we can combine these two x's. Times now, since these are dividing by each other, we simply subtract the two exponents. So that becomes times x to the 15 minus 2r times 2 to the r. Now we want this to be the constant term, and the constant term occurs when we have x to the 0, because x to the 0 is just 1, and obviously the coefficient of that will be the constant term. So like we did last time, we've set up the equation for the constant term in a times x to the 0. Now, having set up this equation, we can see that we've isolated x in one position, x to the 15 minus 2r, and we want that to equal 0. So if we set up the equation, we get x to the 0 equals 15 minus 2r. And this next question is a little bit different, and they were asked to find the constant term in the expansion of x plus 2 on x squared to the power of 15. Now the first step is the same as last time, in that we're going to set up the general term, which is t r plus 1 equals 15 choose r times x to the 15 minus r times 2 on x squared to the power of r. Now we're going to simplify this even more. X 15 minus r times 2r on x to r. See, in the denominator, we simply times the 2 by the r to get x to the power of 2r. So now I'm going to simplify this even more. Now see that we have x to the 15 minus r divided by x to the 2r. We're simply dividing one by another, and they have the same base. So simply, we subtract the exponents from each other. Or the 15 minus r, we subtract 2r from 15 minus r. So that means the general term is going to be simplified to be x to the 15 minus 3r times 2r. Now like last time, we're going to set up this general term to be equal to something. Now, since we're trying to find a constant term, our x is going to be x to the 0, because x to the 0 is simply 1. And therefore, the coefficient of x to the 0 will be the constant term. Now, having set up this equation, we can see that in order to get x to the 0, this right there, that exponent has to be equal to 0. So therefore, 0 equals 15 minus 3r. And then solving for r, we get r equals 5. Now we sub this back into the equation. We get ax to 0 equals 15, choose 5, times x to the 0, times 2 to the 5. X to the 0 cancels out, and we're left with a equals 15, choose 5, times 2 to the 5. And then if you sub that into your calculator, you will get 96,096, and that will be the constant term of that expansion up there. Thank you.